Hello everyone, my name is Yinsen. I'm from Columbia University and super glad to present my current work in NeurIPs 5th Route Learning Workshop. Our project name is Learning Meta-Controller for Dynamic Grasping. Generally, dynamic grasping means there is a movable target moving a certain trajectory, and the robot arm needs to predict the target future pose and plan a collision-free path to grasp and lift the object. Since the dynamic grasping task is very difficult, a state-of-the-art method usually takes a model-based pipeline. As shown in the red image, the pose predictor can compute the predicted target pose based on the prediction horizon and environment observation. Then a time budget will be assigned to motion planner to plan a collision-free path for the robot arm to execute. Many previous works assigned fixed value to these parameters. However, at different time steps within a single episode of dynamic grasping, there should be different optimal values for each parameter, depending on the current scene. For example, in this setup, a small prediction horizon outputs an unreachable predicted target pose, but a large time budget makes the arm stuck into path planning where the target has already moved away. Therefore, in this work, we learn a meta controller to dynamically assign these two key meta parameters step by step. About our method, we first collect current scene observations, then we extract and stack states. We input the states to the meta controller, which is formulated by an agent trained by reinforcement learning. Our meta controller will assign meta parameters to submodulars. One is motion planner, which takes time budget, and the other one is pose predictor, which takes the predict horizon. These two submodulars will give the target future pose and plan a collision-free path for the robot arm to execute. And the observation will be queued in the sequence for the next iteration. We designed two setups to evaluate our method. One is the easy setup. There are a threshold of obstacles between the target and the robot arm. We randomize the target speed, the obstacle pose, the robot arm initial pose, and the type of trajectory at each episode. The other one is a hard setup. There are some cylinders are located on both sides of the trajectory. We keep the type of trajectory as circular, but randomize other things as the easy setup. Here are some demos for the easy setup. We have linear, sinusoid, and rectangular trajectories. The meta controller shows robustness for different trajectories, different target speeds, and different obstacle poses. There are also some demos for the hard setup. The meta controller can still assign good meta parameters to guide the robot arm to grasp and lift the target successfully, even though the setup becomes much harder. We evaluated the performance of our meta controller based on two metrics, success rate and grasping time. We also have two baselines. One is a random policy, and the other one is grid search for the two meta parameters. To sum up, our meta controller gets the highest success rate and the lowest grasping time cost in both setups. To observe what our meta controller has learned, we draw the reachability map for the whole conveyor trajectory. In both setups, the meta controller assigns predict horizon to constrain the target predict pose within the high reachability area, so that the motion planner can easily plan a collision-free path to the target. Thank you very much for your listening. For more details, please scan this QR code to our project website. Thank you.